Hello again. In the last videos, we added appearance, we added decals, we set it up the scene, and we created the rendering. So now, as we can see, we have our final product here. We have our exoskeleton with all the components, we appearance added, we saw how it looks like in real life. But now, the last detail is to talk about its functionality. Well, let's keep in mind that our exoskeleton will be on the hand, yeah, and we'll need to do this motion. Well, what can we do in Fusion to generate this motion? We can make an assembly. We will add a joint, an as-built joint. Well, let's think a little bit our problem. Here we can see that we have the motor and the rod, and when the motor will activate, the rod needs to move. Let's hide a little bit all the components, and I will have only the motor and the rod here. Good. So when I have here, I'll have the rod and the motor, and what I want to select the components to make a joint. So I'll use those components, the rod and the servo motor. And the question is, what type of joint I'll use? We have multiple types. A rigid type that will keep those pieces together, a slider type where, as we can see, the pieces will slide, but for this thing we will need a revolute joint. So the rod will move around the motor. We click OK, we have our joint, we go back, I will show again all the components. Okay, and now I can use the joint to move the exoskeleton. But it doesn't work very well because, as I can see, the rod moves inside the exoskeleton. What I need to do is to stick the pieces together. I need to stick the exoskeleton with the rod. To do this, I will create a rigid group. I go to the assembly again, rigid group, and I will create a rigid group between the rod and the exoskeleton. I click OK, and if I'm doing the motion, I can see that now the exoskeleton moves. But I need to be very, very patient and look around to see if all the components that need to be sticked on the exoskeleton are in the rigid group. So I go again, I make a rigid group, and I will select all these components. Yes, yes. And now let's do this again. The exoskeleton moves properly. I will delete all the rigid group, and now I will test it again, and it works. Okay. Another way to do this rotation and test the joint is making a motion study. I will create a motion study. To create the motion study, I need to select the joint that I want to animate. And here we have our joint at 0 degrees. And I want it to go, let's see where, I think 90 degrees. Let's see. 90 degrees is the wrong value. I need to go with minus 90 degrees. Good. So the motion will be from 0 to 90 degrees. So it will be from this position to that position. And let's see. I want it to be a slow movement that will go back and forth. And I will click play. And as you can see, now I have a motion study, an animation that shows us how our prototype, our product will look like and will function. I can click OK to the motion study, and we can see that the motion study will appear in browser, and every time I need to play it again, I go to Edit, and I will click on Play. Again, I need to select another option if we want to do so, this way or this way, but the motion study will always be in the browser. Well, there we are. We've reached the end of our exoskeleton tutorial. The next things to do are printing the exoskeleton. We ended all the stages to validate our prototype, and now we can go and print it to see if it's printable, if it needs changes, and to see how it will work in real life. Now I can click OK and save, add joints. And in the next video tutorials, we will talk about printing the exoskeleton.